Okay, I think we're just gonna make a start at this time. Today is Friday, and it's our second weekly live online session. As always, it's important for me to offer these chances for us to come together and interact in more immediate manner. But please do remember, like I think you've been really good about that, that this course is asynchronous course. So there's absolutely no expectation of you changing your schedules. This course is built with the intention that you can work whenever you have time, wherever you have time on the weekly materials, as long as you complete those assignments every week. It's up to you when you choose to do so. But because it is important for me that we provide these chances for interaction, we found quite a few ways to do that. We have our online discussion forums, and I'm really appreciative for all of those who have been participating on those, sharing your insights, sharing your observations. I really think that they are a testament to how well you're grasping the material and how you're really kind of invested in your own learning process. So some outstanding work there, some excellent tips and insights on how to tackle the material. So if you ever feel kind of at a loss and are not able to make these live online sessions, that might be one place. I think that most of the people who have posted there have been able to receive really quick responses. I normally try to be super active on those spaces as well to answer to anyone who posts. I am planning that today, unless we have people joining us, then I'll change the plan. But today, since we already have had one live online session this week, and that was our Wednesday session, I think I uploaded a recording of that on yesterday early in the morning. So you have that recording from there, and that goes into a little bit more in detail about the lecture material on the central nervous system. So my plan for today is to keep this kind of more of as a quick, snappy, highlighting the key points of the material. But as always, please do remember that you have the full story on the canvas. You have pre-recorded lecture videos, you have written stuff, you have PowerPoints, you have handouts, all kinds of good stuff. And then you, of course, have your e-textbook. And I really encourage my students to consider those assignments that you complete weekly, not as a test, but more of as a guided activity of what are the key points of the materials. When I put things into those assignments, they're really to emphasize that these are the elements of the learning material that I want you to grab and capture and be very comfortable and familiar with. So I encourage my students to consider those kind of as something that goes along with your study process. You don't have to be perfect just from memory. Use your textbook, use your notes, use your independent research to find those answers and tackle that material. You've taken a few exams with me already. You've also seen that what I highlight on the weekly assignments is very closely to what I highlight in the exams and in practicals. So hopefully we're in a good place on that. I do want, as we're kind of starting and looking what we're covering this week, I want to be totally transparent. I've mentioned it in the past. I've had a couple of super busy weeks. I've been a little bit slower with grading, with reaching out, with responding to questions than I would like to. Normally, I try to respond within a day or two. It's taken me a little longer, but I think I should be now on top of all of that. I've shared with you in the past, I go to the school myself, I work full time, I have multiple responsibilities. So I get it that same applies to you. If you have missed any assignments, if you have missed any exams, if you have missed anything that you would still like to try, even if it's from the past weeks, don't hesitate to reach out to me. I am totally open of figuring out ways for you to collect those points if you missed out on anything. Remember, I'm a big believer that in this course you can collect points in multiple different ways. So if it's not the homework that's your preferred method, you have those alternative ways. I have food for thoughts, assignments. I have a lot of other kinds, participation ways, and so on. So really kind of keeping on track on where your grade is landing. Remember that 91% or anything higher is that A. You don't need to have 100% for that. And really working from that place, hopefully, is helpful as you're tackling the material. And like I said, again, thank you for your patience with understanding that sometimes I'm also scrambling, but we're at a good place now. And we're literally on the finished stretch when I look at the workload for this course. So let's keep up the good momentum. So really the plan for this live online session, like I said, we have more complete, full, longer live online session recording available for you from your Wednesday session. But the plan for this session is really quickly to check in, highlight the homework assignments that I'm looking for you to do, focus mainly time on the highlighting the key elements of the lecture material from this week. I've kind of steered away from going through homework. We did more of that at the beginning of the semester. I think everyone has a good grasp of what to expect with the homework now. But as always, I'm open to changing. And remember that it's important for me that you get to choose what works for you, how I can support you, but I want you to know that I am here to support you. So you can reach out to me through Canvas messages as well, discussion forums, in these live interaction sessions. You can email to me. I normally encourage students to send Canvas messages. My email box is so filled with other stuff that's coming from the college administration side. I always prioritize my Canvas inbox, so that's the quickest way to hear back. But this is not a course where you're on your own. This is a course where very much I want to be here to help you. I also really do want to give a shout out for anyone who has gone through and reviewed their exam and looked at, oh, I thought that this question was kind of tricky, or this one I didn't understand. Could you clarify that to me? That is absolutely what I want to do. I don't want the test to be just like you go through it and look through it and that's what you got. I really want you to kind of use that as a learning chance as well, to return back and try to figure out if there's something you missed, why you missed it. So that's where the greatest learning happens. So please, please, please use me as a resource. That's what I'm here for. That's what I enjoy most about my job. So never hesitate to let me know how I can help you. With that having said, I do want to again say that I'm so grateful to have each and every one of you in this class. You're one of my highlights in my job in terms of I think that this group always raises to the occasion, and the work and learning that you're doing is just, it's a joy to watch it. So I've started doing checking-ins based on a book by Pueblo, looking in boards. We've been picking random numbers. I picked a random number for our Wednesday session. The quote that came up was along the lines, peaceful minds have the power to create a peaceful world. And really what that quote spoke to me about was really the power of our brain, how brain is really the creation, or just the creation of the world that we see around us. So everything, we have sensory organs, sight, hearing, smell, taste, touch, so on. But everything that we gather from the world around us through those organs is mainly just electrical impulses, like we saw with the neurons. And the meaning for those electrical impulses is given at the level of central nervous system, especially your brain. So that's a thought that I often return to, and that's something that I think really highlights the importance for us to understand our central nervous system, understand this week's chapter and content. So I hope that thought helps to justify a little bit why we're looking at the content that we're looking. This week, I have two homework assignments for you. They're very much keeping in line with what you're used to. We're looking of the chapter 14. We have a quiz for that, and then chapter 14, practice anatomy as well. Even though the material on this chapter ventures to both chapter 14 and partially also to chapter 13, the homework questions are fully from chapter 14. I'm asking you to complete both of these by the end of the week, by Sunday. And I'm going to be totally transparent again and say that I'm not sure that the points that I have listed there on the screen are correct. You will be able to see how many points they're worth of by checking the canvas, the assignment there itself, or checking the syllabus. Every semester I do little tweaks on how things are weighed, and I just want to be totally transparent that I would double check how many points worth these assignments are, so you know whether to collect them or whether not, or what's your motives. But I do think that doing those weekly homeworks is really the way to ace this course. So I think that neither one of those is too surprising or too unexpected or too new for you. So it should be fairly familiar place to operate at. So looking at this week's learning material, I really like to start with this slide. We saw the slide earlier on, and I said that what we see here is our nervous system, and everything else in the body is casing and support structures. And that is true. From this model that we're seeing here, we're focusing on the brain and we're focusing on the spinal cord. So we're focusing on our central nervous system. These other nerves that we see here spread out are really to transmit messages from sensory organs to the central nervous system, and from central nervous system to effectors throughout our body. So central nervous system is like this processing part where we analyze the information coming in, we integrate it, we form decisions based on it, we form the perceptions that might influence our decisions, and then we make actions based on that and send messages to do those actions. So I think that central nervous system really is a worthwhile structure for us to spend some time thinking about it. And it's quite fascinating when you look at the history in the past of mankind. For the olden days, we thought for a long time that maybe your heart is where your soul is living, or your core of who you are is based on. And now we really know that if we wanted to associate our personhood, our personality, our planning, our dreams, wishes, hopes, values to somewhere, it probably would be a creation of our central nervous system, and especially our brain. So important structure, important set of structures for us to study. Also, one thing that I find constantly as a researcher fascinating is that we're all unique, we're all different. We have a great amount of variability from one individual to another. Even if we look at the brain, those folds that we see on the surface of the brain, they're all unique from one individual to another. There's some that are more prominent and more commonly repeated on all of us, but we do have a great amount of uniqueness. Yet we can find common patterns from our central nervous system. And it is these common patterns that we learn on this course, but remember always the great amount of variability, great amount of individuality that we see from one individual to another. That's important for us. But I think in order for us to start to tease out those individual differences, we need to understand also the big similarities. And that's what this course hopefully prepares for you. We often look at young, healthy adults in terms of gaining an understanding. Sometimes my students who are going to healthcare careers ask me that why am I learning about young, healthy adult? I'm never going to see a young, healthy adult in clinical practice. And that is absolutely true. Ever might be a too strong of an expression, but most of the time we see patients where things are not working the way they anticipate or we anticipate them to work. But in order for us to get there, we need to first know what's normal. We need to first know what's typical before we can start teasing out those differences. Other thing that I have a kind of affinity and love for is considering comparative anatomy. We often use other species as a source of trying to understand what's unique to us or how we ended up where we're at in terms of the evolution. And most organisms, most living animals do have a nervous system. The nervous system can vary quite a bit based on the sophistication of the animal, based on the sophistication of the organism, but most animals have some kind of a nervous system. Animals with more processing, we see that that nervous system has also a section that resembles our brain, where we really do kind of more of analyzing of that information in the nervous system. We do decision making, we do integrate the information, choose based on that, and send commands to the rest of the body. So I think that that's very worthwhile to be aware of. We use that for our research. We use that to understand unique characteristics of ourselves as we understand then unique characteristics of other animals. We can find what's similar, we can find what's different. So I definitely always encourage that comparative anatomy as an approach. And in fact, we will use comparative anatomy in face-to-face version of this class. My students do end up after they've studied human brain, dissecting a brain. And this brain is a sheep brain that they typically dissect. And what we see is that sheep brain has many similarities to human brain. There are also differences. These differences mainly reflect the differing needs that humans have versus what sheeps have. For example, what are the areas of priority in terms of senses? What are the priority differences in terms of processing? So we compare this human brain to sheep brain. We see similar areas, but we also see differences. For example, humans have an extremely large frontal cortex. So that lobe at the very front of the brain is large, and that lobe is associated with functions like executive functions, planning, having future thinking, having personality, uniqueness in terms of that. I'm not saying the sheeps are not personalities, but I'm saying that probably they don't do as much these things, having like future planning, having executive functions as humans might do. So that lobe is not as prevalent on sheep. Sheep instead, for example, will have very large association area and sensory area for sense of smell compared to humans. We see that also with dogs, cats, that they're able to really rely on their sense of smell much more than humans are. We see the visual processing area of the sheep in proportion of their brain is large, so sheep are very much relying on that. So I think that that's always interesting to see and compare. If you're interested on the sheep brain dissection, I think I have a video of that on your Canvas course, and if I don't have, I will definitely upload it there if anyone's interested. We also see another difference when we compare human brain to many other animals. We see that the human brain is really full from the outside of these folds. It's very wrinkly, whereas some other animals have kind of smoother brain structure. And I think that that's definitely worth exploring a little bit more. And we can explain that when we look at the evolution of the human. What happened from the early human to the current human really was that there was a significant amount of growth of the brain, and especially growth of the brain's cortical area, so that outermost area. The increase in the size of the skull was able to facilitate some of that, but not enough to really fit in all of that increasing cortex. So we needed to find a way to really fit in more cortex to the limited size of the skull. And the way how we've done that was that that large surface area then started folding. So we folded all these ridges and durae on the surface of the brain. We ended up with this really wrinkly brain in sense. And this is um, useful for us in that sense. Um, Here we see really good illustration of the early human. Notice how smooth the brain was, the cortical area, and on more developed humans, how it is much more wrinkly. The size of the brain did grow some, but more than that, their surface area. And actually, that surface area of the brain is where we think that a lot of processing of the information takes place. So that's where the neuron cell bodies are located. In fact, I think that a lot of the time in literature, we can see references to that. If anyone's a fan of Sherlock Holmes books, often I believe Sherlock Holmes says that, oh, I need to go and sit down and dig into my gray matter. What he's saying is that he really needs to do a lot of thinking process, and that thinking process happened on that gray outer surface, the cortical areas of the brain. So some good references there when you look around that you can catch. Another thing that I wanted to introduce here is what happens to our brain throughout our life. And brain and, well, really nervous system is one of the first parts of our body to start to develop. Nervous system, and we'll see examples of that in just a bit, starts developing as just a simple neural tube that then expands and folds and bends to develop the brain part. So that's going to start early in the development, soon after fertilization, and brain keeps developing during the prenatal development and then postnatal development. We see that the greatest rate of growth of the brain is both before the birth and then right after the birth. So the first couple of years are really intense time for the newborn, not only in physical growth and development, but also for the development of the nervous system functions. And we see that the actual physical growth size of the brain starts slowing down as you get older. But even though the mass, the volume of the brain as such doesn't increase, it is worthwhile to notice that we are still fine-tuning things there all the time, where we've seen on this course that learning is very much forming those neural connections, strengthening those connections. And for the longest of time, we thought our students that after you are an adult, after your late teenage years, early adulthood, you do not form new neurons. So that's why things like using substances that alter your brain can cause death to your neurons, like drugs, excessive alcohol use, things like that is really bad because you're losing some of those neurons, and those neurons were what we needed for those processes in the central nervous system. And while that is largely true, yes, we don't form a lot of new neurons. Some of the newer research has indicated that some do happen. But again, I don't by any means encourage you to do those things that damage your nervous system. Rather, just saying that we have a lot that we are still learning about it. I guess that's the big take-home message. Um, like I mentioned, brain starts developing early in their life as a neural tube. And the neural tube, which we will see a couple of pictures in the coming slides, it can be divided into different regions. And these different regions will then give us a rise to the adult brain and different areas that we see within the adult brain as well, including also the rest of the neural tube becoming a spinal cord. So this illustration is something that I often use with my students. We see all the way at the left the neural tube that's present early in the development. And we see from the following box how different portions of the neural tube start to grow and expand. And this gives us a rise, what will eventually give us our forebrain, midbrain, and hindbrain. These parts further develop as we're developing further early in the development before we were born, and eventually give rise to these adult structures. Our cerebrum, with its different parts, our diencephalon, our brainstem, where we see our midbrain pons and medulla oblongata, and eventually, of course, the rest of the neural tube becoming spinal cord. So let's have a look of that. As before we have a look of that, I just want to show also what this diagram really nicely shows is that there's also spaces within the brain where there's so-called empty spaces. It's not actually empty. Those are filled with fluid, our cerebrospinal fluid, and we'll see a couple of illustrations of that as well as we move ahead. But I wanted to show them at this point because I think that we can see the presence of those spaces in the adult neural canal regions that we'll see already early on. So that's kind of interesting to be aware of. So what we're seeing here on the screen is structures of the nervous system of developing individual at 5 weeks after fertilization. So very early in life. And we see that really there's two major flexures that form. These will give rise to our telencephalon and diencephalon. Those areas are then now starting to separate from that neural tube, become more prominent. These colorings on this picture are useful for us to follow, as these colorings will carry through different developmental stages. So you can see how different parts eventually end up forming different parts of the adult brain as well. Here we're seeing these same structures at 13 weeks after fertilization. We're starting to see really already prominent cerebral hemispheres that are taking place. We also see our diencephalon and rostral brainstem that are kind of starting to separate. I think that at week 13 that we're seeing here, we're already seeing a lot of resemblance to the adult brain structures that we'll see later on. There's some arrangement and movement still to take place, but I think it is a very worthwhile thing to notice these characteristics. And here we see brain at the birth. We see the prominent cerebral hemisphere. We'll talk about cerebral hemisphere quite a bit today. That forms the big part of the brain that students often think about, with its outer cortex, all those folds there, but also the inner portions, which is largely the medulla white matter. We see clusters there also, and we'll look at those a little later. We see and this is a kind of a translucent illustration of the brain. We see in the middle of the brain that a diencephalon present there. We also see our brainstem with its three prominent parts: midbrain, pons, and medulla oblongata. And finally, we see what's sometimes known as our little brain, our cerebellum, present there at the back as well. So I think it's fascinating to follow that development. That's actually what I spent my early years as a researcher learning about. And I think that the early development of the human body is just outstanding in a way, how we all end up so well put together, considering how that process is really so delicate. And this is why I guess we could mention here all the toxins and exposures for harmful things like drugs from maternal circulation are so dangerous for the newly developing life. So we want to be very, very mindful about not interrupting those processes, not damaging. There is a very much of a vulnerable period during these stages that the child is going through. Now, next slide that I have shows a cross-section of the fully developed brain, and especially focusing on the cerebral hemispheres. So this is our coronal plane. So we've cut the brain in two halves. We have front and back. And what we see here is really the characteristic appearance of the cerebral hemispheres, that the outer parts of those, so our cortex, is made of gray matter. And remember that this gray matter consists of neuron cell bodies. We see a lot of non-myelinated neurons there. This is, like I said, and this is a little bit of an oversimplification, but it's the processing part of the neural impulses. This is where we analyze the information, combine it, form full experiences, also do a decision making as such. The medulla of the brain, the middle parts of the brain, with the exception of these clusters that we see on darker, but most of the medulla is what we know as white matter. White matter is mostly myelinated axons, and we see really that these parts play important role in passing messages within the brain from one part to another. So that's really really important for forming those connections, forming full experiences, combining messages, combining information from different parts of the brain. So that's our cerebral hemispheres cut through nicely. You'll also see some empty spaces within there, and I'll highlight those in just a bit, but you see them even in this picture. We'll talk about our ventricles. On the right-hand side on this screen, you also see a cross-section through our spinal cord. And what I find interesting about that is that the gray matter is actually the inner structures of the spinal cord, and outer structures are outer white matter. So the order kind of flips around. And sorry, I'm just looking around. My cat is being a little naughty and desperate for attention. So just keeping an eye off of her. And if you see me looking off the screen, that's why. Why? You're desperate for attention. Why don't you join us? So she might join us for a little bit. We'll see. So what else? I've mentioned a few times now in passing that inside the brain there's also empty spaces, so to speak. These are not really empty spaces. They're not nervous tissue. They're spaces where fluid circulates it in, and this fluid is our cerebrospinal fluid. Cerebrospinal fluid bathes the brain and central nervous system, including also our spinal cord. So your brain sits, and this is a course over simplification, but your brain sits within the skull that's filled with fluid. It's like a brain sitting in a big bucket of fluid, and this fluid helps us in multiple different ways, including providing us a method to pass chemicals around, including us providing us a little bit of a way to kind of soften any impact, so we don't get as much whiplash if we end up into an accident, for example, and things like that. And all of these different empty spaces, which are known as our ventricles, are named differently. So in your later studies, you'll get to learn a lot more about those. But those ventricles are definitely something that many of my students in their further studies end up learning about and end up studying. And notice that that cerebrospinal fluid continues also to your spinal cord along there as well. So that's an interesting thing to notice as well. If we look at the brain, and especially the cerebral hemispheres, we of course have two cerebral hemispheres, right and left. The surface of the cerebral hemispheres is characterized by these kind of sausage-looking ridges and depressions. We call those ridges uri, and we call those depressions sulci. We also have very deep depressions, very deep grooves, and these are known as our fissures. And there are, like I mentioned, variability in the gyri and fissures from one individual to another, but there are also similarities that we see. Some of the most prominent fissures, we see those in most humans, and those have become very important for us as anatomical landmarks. So we see longitudinal fissure dividing our cerebral hemispheres into left and right. I've highlighted that as a yellow line or orange line there on the bigger picture of the brain on the left bottom corner of the screen. And transverse fissure then separates that little brain from the cerebral hemispheres that we see as well at the top of the screen, at the left top corner. We will see a few other fissures as well, and these fissures are really used to separate lobes of the brain, different parts of the brain, and we can then associate different functions to these different lobes of the brain. So let's have a look of that. Here we see a brain. We see the central sulcus, which separates the frontal and parietal lobe following the coronal plane. So kind of centrally at the top on this screen, we see our lateral sulcus on the side separating our temporal lobe from the rest of the cerebral hemispheres. We see our parietal occipital sulcus at the very back, separating our occipital lobes at the very back as well. And then we see the transverse cerebral fissure separating that little brain from the cerebral hemispheres. Based on these sulci, we can now separate different lobes of the brain. So these lobes are largely named based on the bones that sit on top of them. So frontal lobe is the very front part of the brain. Frontal lobe, like I mentioned when we were comparing sheep and humans, a lot of things that are housed in the frontal lobe are kind of more advanced processing and more advanced nervous system functions, for example, executive functions. I mentioned personality, dreams, wishes, hopes, future thinking. At the very back of the frontal lobe, we also see primary motor area. So we're coordinating motor actions to the different parts of the body. And in fact, different body parts are represented there, giving us a structure that we call homunculus, which really the area dedicated on the cortex of that region at the primary motor cortex represents how much innovation we have for the motor functions of that body part. Then behind the frontal lobe, we have our parietal lobe. Our parietal lobe really is dedicated for sensory processing, and we see right at the front of the parietal lobe, right opposite to that primary motor cortex on the frontal lobe, on the parietal lobe, we have primary somatosensory cortex. And similarly, primary somatosensory cortex has different regions represented based on the importance that we allocate to those areas. We have at the very back our occipital lobe. Our occipital lobe really does visual processing and kind of fine-tuning those visual information. I often think of that with my students, that it's quite amazing that our eyes convert variations in the light waves into neural impulses, so electrical impulses that pass all the way to the back of the brain before we get the visual perception of what we're seeing. That's why I guess that we're also seeing that I made a reference a few times that expressions that we have. Can you stop dropping my stuff? Sorry, I was speaking to my cat. The expressions that we have, for example, in cartoons, you might sometimes see when someone falls over and hits their head and back of the head, they see stars. Well, that would be because their visual area is literally activated. So we might have visual misinterpretations there taking place if there's an impact to that area. And then finally, I wanted to mention our temporal lobe at the sides. These are really areas dedicated for speech production, language comprehension, hearing, things like that. I put in brackets here an area called insula. Insula is located deep between the frontal and temporal lobe, and we won't go into that on this course, but I wanted to mention it in case you sometimes hear about the fifth brain area, lobe of the brain hemisphere that you will learn. So that is located there. We have done a lot of location of further structures as well. I've highlighted there with blue dots, the one more anteriorly, so more towards the front, is going to be our Broca's area, which is important for speech production. One more posteriorly, more back, is going to be our Wernicke's area, which is essential for speech, understanding speech, analyzing speech, comprehending it. So a lot of these different functions that we've allocated to different areas of the brain are really a result of early days of studying brain injuries. So if we had someone who had an injury, their behavior was changed, we recorded that, and after their passing, we studied what's going on with their brain. We talked about, for example, of a famous case of Phineas Gage at last week. In addition to that, these days, medical imaging techniques have changed the game a little bit on this. So we're able to ask patients to perform certain functions and then do, for example, functional MRI or do other kinds of imaging of the brain and follow which areas of the brain are particularly active when they do those functions and locate those functions based on that as well. Looking other parts of the brain, we've talked about cerebral hemisphere. Let's have a look of diencephalon. Remember, this was a picture where that kind of shows transcendently true. Diencephalon is located deep within the brain in there. And a couple of parts from there that I want to highlight. We see our thalamus, kind of egg-shaped structure on both sides, right and left. Immediately underneath thalamus, we see hypothalamus. Literally the word telling us below the thalamus. Importantly, from hypothalamus, we see that hanging underneath is our pituitary gland. And that's going to be something, the hypothalamus and pituitary gland, that we'll be talking a lot when you start your BIO202 and we look at the endocrine system, so hormonal system, and we see really that hypothalamus serves as our master gland for the endocrine system, controlling all other hormones and glands that secrete hormones, glands that are responsible for producing hormones. I also wanted to highlight from the very back, pineal gland from the epithalamus. Pineal gland is a gland that's responsible for sleep-wake regulation through a hormone called melatonin. We'll get to talk about that more also at BIO202, but you can see over-the-counter products for kind of adjusting your sleep-wake pattern. You can also get prescription stuff if people have issues with regulating their sleep-wake pattern. I next wanted to mention, kind of briefly fly through the brainstem, shown in green on this picture. Part of it is inside the brain, part of it is outside. We see there our midbrain, our pons, and our medulla oblongata. In fact, this is one of the first parts of the brain development to start to develop. This is evolutionarily one of the first parts of the brain that develop. And these parts house really crucial functions for our survival. So regulation of vital functions like heart rate, for example, or respiratory rate, things like that. So I often think that they're nicely protected there as well to protect these vital functions. So an injury to the brainstem would have more than likely catastrophic consequences. In my previous live online session, I go into more detail about the different parts of the brainstem, but for our purposes today, in the interest of time, I'll just mention that this is also kind of a area where we do filtering and choosing what information actually gets passed further, what's important. Remember, our sensory organs collect all the time sensory information, and there's so much information that if everything became to an awareness, we would be overwhelmed with that amount of information. So we need to choose what's important as well, and brainstem plays important role on that process. Now, to kind of wrap off, let's have a look of the cerebellum at the very back of the brain, that what I've been referring as a little brain. This is really important for movement coordination. I have a ballet dancer in my other class, and we often talk about her cerebellum is probably very well developed to coordinate that. So coordination of movements, balance, things like that. If we do a cross section through the cerebellum, we see these white myelinated tracks running inside there. Those are known as our arbor vitae. So that means a tree of life. And arbor vitae is responsible for really kind of coordinating passing messages, but it's a beautiful structure, and I think that we can see the tree-like appearance there coming from the Latin words, so I wanted to highlight that as well there for you. And this really brings us to the very end of everything that I wanted to highlight as key points from this week's learning material. As I've said earlier on, and as I keep emphasizing, please remember you're not alone in this class. Even though it's an online class, it's very much doesn't mean that you wouldn't be supported. I am here to support you. I'm here to answer questions, clarify things. So please use me as a resource. And this is one of my favorite things to do, to be there available for my students. So please consider that. And that really brings us to the end of this session. Like I keep saying, but I keep saying it because I really mean it. This is an outstanding group of students, each and every one of you in this class. I so appreciate you, and I am so grateful that you're part of this class. You're doing fantastic job. I know I take some classes myself online as well. Sometimes it might feel like there's just chore after a chore. Is it being noticed? And I want you to know that I go through each and every one of your grades every week. And I see the fantastic work that you're doing. I'm seeing the excellent effort that you're putting in. And I'm so grateful, so happy to be able to be part of your journey of learning this course's materials. So I look forward to continuing working with you in our online spaces, discussion forums, through our assignments, through feedback, through that communication. Remember, I'm always only a message away. And even if these live online sessions don't work for you, I often meet with my students outside my virtual office hours. All you have to do is let me know that you want to meet. I will find the time that works for both of us, and we can meet either through a phone call or through online video conferencing, or I'm also available on campus as well. And I'm pretty much on the campus from early morning till late at night. So I bet you there's a time when we can meet. Again, thank you for being part of this class, and I very much look forward to another great week of learning and working with you. Until I see you at the next time, in whatever form and shape it takes, take care, and let's make it another fantastic week. Bye.